This video will be discussing causation and other aspects of causation. In a nutshell, causation is simply, as one thing changes, something else responds because of it. A couple facts about causation is just because we see a strong relationship between two variables doesn't necessarily mean that one is causing the other. I might look at data and find out that every time the temperature in Russia is below freezing, my test scores are higher. Now, the temperature in Russia is not causing my test scores to be higher in any way, shape, or form, but there could be a very strong linear relationship nonetheless. The next thing about causation is that it's often influenced by what's called lurking variables. They're variables or things happening that are affecting the response variable, and we either can identify it or can't identify it, but either way, it's fiddling with the response variable and clouding our ability to determine causation. Finally, the only way to truly establish a cause and effect relationship is through a comparative randomized experiment. That is what is called the gold standard for causation. Now, there's essentially three different levels. The first, causation. As one thing changes, something else responds directly because of that. For example, temperature is a direct cause of my heating bill. If the temperature plummets, I need to warm my house, therefore I use my furnace and my heat bill goes up. If the temperature is high, I don't need to heat my house. It's a pleasant area or pleasant temperature, so I don't use up the heat. My heat bill stays low. The temperature causes my heat bill to either go up or down. The second type is common response. Let's say I look at ice cream sales at the beach and drownings. I'm noticing that as my ice cream sales increases, so does my number of drownings. Well, how could that be happening? Are people eating ice cream and then going out and swimming and drowning? Is that what's happening? Or are they both reacting to some unknown third variable? In this situation, being summertime or the temperature, so summertime and temperature are what's actually driving both of these to increase. As the temperature goes up, people are going to want to eat more ice cream to stay cool. As the temperature goes up, you're going to have more people swimming, thus increase the number of drownings. So ice cream sales isn't causing drownings or vice versa. They're both reacting to a third variable, the time of the year, the temperature. Finally, the last one is called common response. Or not common response, confounding. So an example of confounding, or brief description, is when two variables are acting upon my response and I can't distinguish what is causing what. It can either come from a lurking variable or it can come from a poorly designed experiment. So the example that I'm going to use for this is, let's say that I'm noticing, I'm looking at students' scores. And so what I'm looking at and for that is TV time. I notice that as a student's amount of TV watching goes up, their scores goes down. As the amount of TV they watch goes down, their scores tend to go up. However, there could be a third variable, parental involvement. That's also affecting the scores. A student that's watching a lot of TV may be doing so because their parents aren't around or their parents don't care or something like that. Parents that tend to be more involved, students tend to have higher scores. Parents that are less involved tend to have lower scores. So is it the amount of TV they're watching, or is it the parent involvement that's causing the change in the scores that we see? So that's an example of confounding. Another example of confounding where let's say I was running an experiment and I wanted to see how sleep and exercise affected a person's ability to do basic tasks. And so I had one person sleep 8 hours a day and exercise for 30 minutes. The other person I have sleep for 4 hours a day and not exercise at all. If I noticed that the results for the person that exercised and slept more was that they performed better, well, is it they're performing better because they got more sleep, or is it the exercise, or is it a combination of both? So that's how you'd see confounding in a poorly designed experiment. Now, unfortunately, we can't always do an experiment. Some things are either too expensive, too hard, or too unethical to do. The best example of not being able to do an experiment is smoking. We know now that smoking causes cancer. However, back in the 40s and 50s, it was just starting to be discovered. People said, look, we're noticing that people that smoke a lot tend to have higher rates of cancer in their lungs. So their burden of proof was showing that this was, beyond a shadow of doubt, the responsibility of cigarettes causing the cancer. They couldn't run an experiment and randomly assign a group of people to smoke for half their lifetime and another group not, and then compare cancer rates. That's unethical. You can't have somebody do something that you think could kill them or cause them to have cancer. So instead they had to rely on observational studies, looking at medical data, looking at people with lung cancer, and evaluating how much they smoked and so forth. By doing that over the period of decades, they were able to prove that smoking cigarettes causes cancer. So there's several things that you have to look for when you're trying to use an observational study to establish causation. First, the association is strong. We should see that as one variable increases, the other one responds accordingly. And it happens if it's increasing, if it's decreasing, and it's a very consistent relationship. That's the next part, is it needs to be consistent. It can't only happen for just low values or just high values. It has to be happening no matter what values we're looking at. Higher doses associated with stronger responses. So like smoking, the more I smoke, the faster I get cancer. Something along those lines. The alleged cause precedes the effect in time. Well, am I smoking first and then developing cancer, or were they actually developing the cancer and then smoking? So you have to look at something like that. And then finally, it has to be plausible. Sometimes you might be able to show all these other things, but it's not actually plausible. So when you cannot do a randomized comparative experiment, you have to use well-designed observational studies, a lot of them, and you need to check that those things are going to be met. Thank you.